Hey guys. Alright, now we're going to do section 3 from chapter 7, which is called the multiplication counting principle. So basically we're going to talk about how you can figure out the total number of elements in a sample space just using multiplication and not actually listing them all out like we have been. So the multiplication counting principle says if you let A and B be finite sets, that means that they are not infinite, they have a finite number of things in them. Okay, then the number of ways to choose one element from A and then one element from B is the number of elements in A times the number of elements in B. So let A equal 1, 2, 3, 4, 5, 6. And let B equal H and T, so heads and tails. Okay? In how many different ways can I choose one element from A and one element from B? So I want to have one element from A and one element from B. What I can do is I can use my multiplication counting principle, so I can say that I have the number of elements in A times the number of elements in B, which in this case is going to be 6 times 2, which would be 12. So there's 12 different ways that I could pick one element from A and one element from B. And then it says, what is the probability of choosing a 2 and a T? Okay, so I want a 2 first and then a T. Well, if I have that, I know that that's just one possible way that I could get one element from A and one element from B out of my total number of outcomes, which is 12, so 1 out of 12 would be that probability. Okay, we also have our theorem, which talks about selections with replacement. Let S be a set with n elements, then there are n to the k possible arrangements of k elements from S with replacement. So what does it mean by with replacement? That means that after I take an element out, I'm going to put it right back in, and it's back to being randomly selected. Okay, meaning that if I put it back in, I could take it back out right away. It doesn't necessarily mean that I'm going to, but it should be random, meaning that you have an equally likely chance of getting that element over again. So how many license plates are possible with 4 letters from A to Z, followed by 2 digits from 0 to 9? The way that I personally like to approach these problems is I like to kind of write out some blanks and think about the possible ways that I could choose one of the elements from each of the blanks. So if I want 4 letters followed by 2 digits, I'm just going to do 4 blanks for letters and 2 blanks for digits. Okay, so I've got a total of 6 blanks. Now, if I'm replacing each of these letters afterwards, meaning that I can use them over again, I'm going to have 26 possible ways that I could get a letter. So each of these are going to be 26. There's 26 ways that I could choose those letters. And then I want to follow that by 2 digits from 0 to 9. 0 to 9, that's 10 possible ways that I could get those numbers. So each of these are 10. So essentially what I have here is I have 26 to the 4th times 10 squared. Okay, so the way that the book tells you to do it is just to start off with this, okay, which is fine if that's something that you understand. I personally like doing the blanks first because I feel like that kind of makes it a little more concrete in my head. Alright, so if I put that into my calculator, I get 45,697,600. And that is the total possible ways that you could choose those license plates with replacement with 4 letters followed by 2 digits. Alright, next up we've got n factorial. N factorial is written as n with an exclamation point. The exclamation point does not mean that it's excited. It means that it is a factorial. It is a math symbol. Okay, basically what it means is that you're going to multiply it by each integer in decreasing order until you get down to 1. So for example, if you have something like 9 factorial, that's going to be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, you don't go all the way down to 0 because if you did, it would just cancel out all the work you did. So you stop at 1, and that's going to be n factorial. Okay, so the proper way to write it is, or by definition, n factorial is n times n minus 1, right? So I'm subtracting a number from my n times n minus 2, so I'm getting even smaller. I'm subtracting another 1 off times n minus 3, and you're just going to keep going down until you get down to 2 and then 1. Okay, so you're just multiplying all those numbers together. Alright, so let's calculate 6 factorial. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. If you plug that into your calculator, you're just going to get 720. Also, your calculator will do the factorials for you. So if you type into your calculator 6 with an exclamation point, so for the exclamation point, you hit the math button, and you go over to PRB, which stands for probability, and you scroll down to the fourth one, which is an exclamation point, and you hit enter. You can type in that 6 factorial, okay, and then you can hit enter, and that'll just give you 720. Alright, next one is 10 factorial over 5 factorial. So if you have 10 factorial over 5 factorial, remember that the way you can write that is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 5 factorial is 5 times 4 times 3 times 2 times 1. So this 5, 4, 3, 2, 1 cancels out, and all you have is 10, 9, 8, 7, 6 that you're multiplying. So that would give you 30,240. Alright, next up we need to talk about selections without replacement. So without replacement means that I take it out and I don't put it back in at all. Okay, so basically it's changing my sample space every time that I take something out. So, how many orders of finish are possible in a 7-horse race? So I know that if the one horse gets first place, now first place is gone and none of the other horses can get first place anymore. Okay? So I again like to start this by putting out my dashes. So if I've got a 7-horse race, that means I'm going to have 7 dashes. Okay? So for first place, how many horses do I have to choose from? Well, I've got 7 horses, so I know that I can choose from 7 horses. Now, for second place, I only have 6 horses to choose from, so this is going to be 6. And then for third place now, I only have 5 horses to choose from. I think you get the drift. This is going to end up being n factorial, okay? So in this case, it's just 7 factorial, which when you plug that into your calculator, you get 5,040. So there's 5,040 ways that you could have horses finish in a 7-horse race. Alright, so whenever you have something that's with replacement, it's just n to the k, and whenever you have something without replacement, it's just n factorial. Alright.